Well, all the connectors intended for this service are 50 ohms. You can special order the, 46.5, whatever it is for the 93 ohm that Intel wants. You can special order those, but the rest of the world is all 50 ohms. And the primary concern with these high pin count connectors are these. Want to make sure the plated through holes used to connect the pins have been managed as described with all the other plated through holes, meaning that we back drill if we have traces that are in the upper layers of the board. Make sure the receive ends of long data paths with lots of loss are separated from the drive ends, which don't have much loss. Again, that's crosstalk. And of course, all the newer connectors that are intended for this service are well isolated rows, so that you can have a row of drivers here right next to it, receivers, and there's enough isolation to keep that from having a crosstalk problem. So flexible circuits are viewed by a lot of people as mysterious, and I'd like to take that mystery out of that. We used thousands of them in that supercomputer with great success. And flex circuits are rarely more than 2 layers, and you do not need more than 2 for these high-speed signals. You can't do it with 1, and the reason you can't is because you'll have a crosstalk problem. And so it's a 2-sided flex circuit. It's surface microstrip. Nothing real magic. You design it just like everything else we just did. What you'll have for a problem, depends on whether it's a problem or not, the laminate is going to be 2 or 3 mils thick, which will mean that your trace width is going to be 2 or 3 mils. So there'll be more copper loss in those traces than if you had a 4 or 5 mil trace. But otherwise, there's nothing magic about a flex circuit. And you, of course, hook the planes of the flex circuit to the logic ground at both ends.